All right, this is 2007 Form B number 4, and it's a derivative graph. Here's the derivative graph drawn for you. I went ahead and marked what the areas were in each of the shapes because you're going to need that going forward. And you were told that f of 1 is equal to 3. Part A says to find the values of x where f has a relative max and justify. Well, you're looking at the derivative graph, and maxes occur when the derivative changes from positive to negative. So that's happening right there, and that's happening again right there. And those guys are x equals -3 and x equals 4. All right, part B. Between -5 and 5, find all values of x at which the graph of f has a point of inflection and justify. All right, inflection points occur when the second derivative changes sign. And another way to say that are the relative extrema of the first derivative. So if you're looking at this guy, he's got a relative max here, a relative min here, and a relative max there. So -4, -1, and 2. And these are relative extrema for f prime. Part C, find all intervals on which the graph of f is both concave up and has positive slope. Do this in the order of the derivatives. Positive slope means positive f prime values. Positive f prime values are the guys that are going to be above the x-axis. And then concave up means you're going to have positive f double prime. And positive f double prime, or f double prime, is the slope of f single prime. So I'm looking to see where in the region I'm allowed to look at we have positive slope. And that's happening right there. And it's happening again right there. So my intervals are -5 to -4 and 1 to 2. And that's just simply both f prime and f double prime are positive on those intervals. Part D, find the absolute minimum on the closed interval from -5 to 5. So as soon as you see that closed interval, absolute min or max, make a table. You have to prove it. Okay, you're told that f of 1 is equal to 3. And so that's the first thing I put in my table. As Tyler would say, that's the initial condition. All right? And so from there, you're going to go forward, and you're going to reset yourself and go backwards. Okay, so if I'm right here and I'm going forward, I got to get to an x value of 4, and 3 plus 3 is 6. Okay, and then I got to go over to here. 6 take away 1/2 is 11/2. So now I'm here. So I've taken care of this side. Now I got to go backwards. So I reset myself back to here and go this way. Okay, that's below and to the left, so he counts positive. And then that is to the left and above, so he counts negative. So I'm just taking pi over 2 away from 2 pi essentially. Puts me to here. If you look at the outputs, the initial condition is the smallest, so that's your absolute minimum.